Hello, my name is Robi Hassan, and this is my video demonstration for the analysis of algorithm class COT6405 programming project. The goal of this project was to implement, test, and analyze two different algorithms for solving the closest pair of points problem, a brute force algorithm with a time complexity of theta of n square, and a more efficient divide and conquer algorithm with a complexity of theta of n log n. To make the analysis and demonstration interactive, I have built the entire project as a self-contained web service using Python and Flask. The dependencies related to Flask are available here, and I'm also running a Python version of 3.12. To run the test, we can run Python test algorithm, which is this test file. It can run a couple of those tests. However, there is other way that we can run using the Flask, where we can do Flask run. And when I open this URL, it should open this application in our browser where I have an input where I can put the total number of points, and that will gonna create the scatter graph as well as the n values, which is comma separated. I can put only 100 for testing here in this case, and for the demo purpose, and for here as well, I can put some small value. And when I hit enter, it should create the visualization. While it's running in the background, let's explain how the application setup works. The application initially start with this app.py, and which render a index.html is nothing but a template which render all those HTML file. The core logic of this program is start from this algorithm and this generator as well. And there is some code related to the experiment which is here. So first of all, the input file that we send 100 and this n value are resulted in here, the n and then all n values. And we have a m value equal to 10. So basically, when the algorithm runs for each of those m value 10 times, it's gonna generate a random distinct point. This is the function which does that. What it does is like I pass the n, and for this n, it's gonna create all those distinct point into this list, and it return me those all distinct list, and that has create the scatter graph with those distinct list. And then here all the n values that we pass from here 100, 200, and 500 on all those is running on a loop. And whenever I'm running any of those algorithm, if you see, I'm taking a timestamp count start, and then I'm always taking the end count of this timestamp, and then I'm subtracting start and end to keep the time in my time one for same as for other algorithm I'm putting into time two. And with these values, I'm able to generate for each range of m value. So if I get 10 times, what I'm doing is I'm doing a average value of this to make sure I'm always get a constant average value of each of those points. And then when I have those average value, I am using those value to find my C in here to get the max ratios. To get the ratios, I'm just getting from this average value, which is this, divided by T1, which is the T1 of n square. Each time I'm gonna get this value, I'm using this C1 and C2, which is the max value of this ratio of algorithm 1 and algorithm 2. Let's explain the algorithm now. So I have this algorithm first. Let's talk about the brute force. This is n square. So basically, I'm looping one time and second time. So basically, it's a 2D array. I'm kind of like looping up each of those value, and I'm calculating the distance from one value to another value. To calculate the distance, I'm using the Euclidean formula. And then once I have the distance, I'm always taking the minimum distance. On divide and conquer, I had this util function called merge sort to split this array. And this is nothing but a smaller implementation of merge sort to split the array into two halves, and then sort each of the halves separately. And then I'm pushing those two array into a recursive function, which run on another recursive here to conquer each of the split section of the array, and I'm returning the data in here in the closest value. And here also I'm doing the same thing using the Euclidean matrix to find the distance. So that's pretty much in terms of the code. Let's explain on the UI. So after running 100 of the points, I have the shortest distance between pair these two. I can run another time, and this is going to create another random points, because as I have discussed in generator, I'm always generating a random coordinate. So this time I have these 2 points are closest pair. And also we can see that the value of n from 100 to 1500 as well, which I have the empirical runtime analysis as well as the as the predicted runtime analysis with the ratio of this value. And if I look at the first chart, I can see that for the algorithm 1, which is the red color, have a very high significant raise of this value, which means that after each of those 10 analysis run, my red color clearly show that the brute force algorithm grow quartically and shoot up very high, where on my divide and conquer is growth rate is very slow. And then on this graph, and this graph show my empirical value and predicted value. First one is the algorithm 1, and second one is the algorithm 2, where I see that the empirical value, which is the solid line, is very close to my predicted line, which means it is using the it is able to use my predicted formula of n log n as well as n square. That concludes my demonstration of this algorithm, and thank you very much.